In question number 41, it says that the internal energy of a gas is given by U is equal to PV by 2. At constant volume, state of gas changes from P0 V0 to 3 P0 V0. Then, since the volume is constant, so we can say that work done will be 0. And if work done is 0, then first law of thermodynamics says Q will be equal to del U plus W. And since work done is 0, so we can write Q will be equal to simply delta U. That means U final minus U initial. And we know that U is given as PV by 2. Initially the pressure is P0, volume is V0. Finally pressure is 3 P0, volume is V0. So we can write 3 P0 into V0 by 2. This is our final energy minus initial P0 V0 by 2. So we can say that this will be equal to P0 V0. So this is the heat. And since it comes to be positive, so we can say that this heat is absorbed by the gas. Heat given to the gas, heat absorbed by the gas will be equal to positive. Heat taken from the gas or heat rejected by the gas will be negative. This is the amount of heat absorbed by the gas. So if I look at the option, first option says heat rejected, false. Heat absorbed by the gas is P0 V0. So this is our correct choice. Work done will be 0. So this is wrong. And fourth option says heat absorbed is 3 P0 V0 by 2. So this is wrong. So our option number 2 will be the correct choice. Now let's move to the question number 42. In question number 42, it says that an ideal gas is found to obey the law V square T is equal to constant. The initial pressure and temperature are P0 and T0. If gas expands such that its pressure becomes P0 by 4, then the final temperature of the gas. But in question, volume temperature relationship is given and they ask about the pressure and temperature. So we have to first convert volume temperature equation into pressure temperature. So how do we do that? This equation is given, right? So we know that PV will always be equal to nRT for an ideal gas. So volume can be written as nRT by P. So if I put the volume here, so we can write nRT by P whole square into T will be constant. So we can write T cube by P square will be constant, right? So if I use this, then we can get the pressure. So according to the question, initial pressure is P0 and temperature is T0. So we can write T0 cube upon P0 square will be equal to final temperature, final pressure. So final temperature we have to calculate. Final pressure is given P0 by 4. So let's say final temperature is TF whole cube divided by P0 by 4 whole square. So P0 will cancel out. So we can write final temperature will be equal to 1 by 16. 4 square is 16 to the power 1 by 3 into T0. This is our final temperature. So we can write it also like this, T0 divided by 16 to the power 1 by 3. So my option number 3 will be the correct choice. Now let's move to the question number 43. In question 43, it says that the given figure shows the pressure temperature diagram for a fixed mass of an ideal gas undergoing cyclic process ABCA, the corresponding pressure volume graph for the given cycle. So pressure temperature graph is given, we have to draw the pressure volume graph. So first we will identify what are the processes and what are the things given. So in this process, as you can see that A to B, if I move from A to B, so AB is what? Straight line passing through origin. So we can say that pressure will be directly proportional to temperature. And if the pressure will be directly proportional to temperature, so we can say that volume will remain constant. So basically AB is an isochoric process, right? Now if you look at BC, so in BC, as you can say that this axis is perpendicular to the temperature axis. That means temperature will remain constant. So for BC, temperature is constant. And if the temperature is constant, so we can say that pressure will be inversely proportional to volume, right? And CA, what about CA? CA line is perpendicular to the pressure axis, and if it is perpendicular to the pressure axis, so we can say that pressure will be constant. And if the pressure is constant, that means it is a isobaric process, that means volume will be directly proportional to temperature. So if you look at this four option, here AB constant volume, BC isothermal, and CA pressure constant. So yes, this graph satisfies all the choices, right? So we can say that our option number 1 will be correct. Now let's look at the other option. Here AB is the volume constant. Yes, it is correct. In BC, this is not an isothermal process. This is not a P is inversely proportional to V. So this is our wrong. If you look at 3, so AB volume constant. Here the BC line is perpendicular to the pressure axis. So this is pressure constant. But here the temperature was constant. So this is also wrong. What about fourth option? Fourth option again, AB pressure constant, but AB volume constant. So this is also wrong. So we can say that our option number 1 will be the correct choice. Now let's move to the question number 44. In question number 44, it says that which of the following is incorrect, right? Option 1 says if two systems A and B are in thermal equilibrium with system C separately, then A and B will be in thermal equilibrium. Yes, this is zeroth law of thermodynamics. So this is our true statement, right? Second, zeroth law of thermodynamics defines temperature. Yes, zeroth law defines the temperature because zeroth law talks about the thermal equilibrium, and when two bodies are in thermal equilibrium, then their temperature must be same. So yes, we can say that zeroth law of thermodynamics defines temperature. So if two bodies are in thermal equilibrium, then they will have same temperature, right? Third option says that, so this is also true. Second option is also true. Third option says that temperature does not determine the direction of flow of heat when two bodies are in place in thermal contact. This is wrong because the heat always moves from high temperature to low temperature. So the temperature is the deciding factor for the direction of flow. So this is our false statement. Fourth statement says that internal energy of an ideal gas depends on the state of the system. Yes, internal energy only depends on the temperature, and temperature is the state. So internal energy is basically a state function. Yes, so this is also our true. So we can say that our option number 3 will be the correct choice. Now let's move to the question number 45. In question number 45, it says that which of the following graph does not belong to isothermal process for an ideal gas. So we know that for isothermal process, temperature should be constant. And if the temperature is constant, that means pressure will be directly proportional to 1 by V. Or you can write PV will be constant. Right? We can write it like this. So if I draw the graph of PT, so if you look at option 3, so PT graph, since PT diagram, the line is perpendicular to the temperature axis. So yes, temperature is constant. So third option is the correct, right? Second option, pressure and 1 by volume. Since pressure is directly proportional to 1 by volume, so yes, this graph will pass through a straight line. So yes, this graph will be a straight line passing through origin. So this is also correct. Option number 1, PV is equal to constant. Yes, PV is equal to constant also satisfies this equation. So first is correct. But in fourth, volume and 1 by T graph. Since temperature becomes constant, so 1 by T will also be constant. So how the temperature will increase? So this will not increase. So we can say that the fourth option will not represent the isothermal process. So question says which of the following graph does not belong? Yes. So our fourth option does not belong to isothermal process. So our correct choice will be our fourth option, right? So this is our correct choice. Okay. So this is our complete paper. Thank you everyone. We will meet again. Thank you students.